Good morning. I hope you're doing well. I'm doing not as well as I would like to be doing, but we're getting there. I spent so much time in the last week really trying to get Ball Butler to be functional for this. I was thinking at around Friday afternoon after the last stream and through Saturday and even Sunday, I was thinking that maybe I could get Ball Butler to, we could potentially, for this 100th video on my channel, we could potentially get the first inter-robot throw between Ball Butler and Jugglebot. But as the week wore on, I realized that was progressively becoming less and less achievable, as there were just so many things that I needed or wanted to change, and I kept having this little mantra in the back of my mind running that if it's worth doing right. And every time I told myself that, I would I know that that's the case, but I hate that that's the case because doing things right usually takes a heck of a lot longer. So we're very close, and I'm very excited to show you all the changes. This has been a very, very, very busy week for Jugglebot. There's a lot of stuff to go through, but for better or worse, I guess for a good thing on the stream, a lot of this stuff that I've done was just a lot of CAD work, but it's pretty quick to run through what those changes were. So before we get too into it, I want to show you where we left off last week. I just want to remind you what everything looked like this time last week. So we had, I don't know, there's a bit of a gap around here. It's not very nice. Don't like seeing that exposed metal. We've got the motor sticking out the side here, which is yeah, cool. It's kind of tight and kind of neat, but is what it is. And then the base was just completely unfinished, full of holes that were not supposed to be there. And this was not fleshed out. It was incomplete. And so just kind of hold this picture in your mind. And now I'll show you the real thing first, actually, because I can now. It's very exciting. Ta-da! We have Ball Butler. I ran out of black filament, which is why the base is all purple, and I've got more to talk about with that a bit later. But yeah, it's all together now, and it's pretty hefty, all things considered. I'm kind of surprised at how much it weighs. But yeah, so this, we can go up and down, on here. It's all very nice. But I'll show you on the CAD what these changes actually were. So, this is what we look like now. And there's a link in the description for this CAD as well if you want to check it out. You can follow along. So now, I flipped the motor around so that rather than the hand motor being sticking out on the left-hand side over here, it's now tucked in nice and neat on the right-hand side, meaning that everything is very sleek on the right here. Now, the thing that took probably the most amount of time is that as of last week, there was a big problem with this design, which was that as this big motor here spins to move the arm up and down, the only way that motion is being transferred over to the hand section is via this string spool. And that was not very good. I was not super happy about that because this is currently just printed. It will hopefully later be made of aluminium, but even so, that component should only need to be rotating and spooling and unspooling the string. It shouldn't need to actually transfer any force between these two components. So that was, I don't know, I think perhaps overextending the abilities of that component. So what I've done is, and I mentioned last week that what I would like to do, and I was hoping that someone would convince me to do it, but I ended up just convincing myself, is to basically combine, put in some fashion, fix these two components, the two highlighted parts, together, so that way, even if this spool isn't here, then these two components are still merged together and they still have to move together. Now, there is one very small other thing that's working to hold these two components together, which is that both of them are clamped onto this M8 dowel that runs through the middle here. Both of these arms are being clamped onto that. So they are kind of linked together that way, but that's not, I don't want to have to rely on only that and the spool. So, after a lot of umming and ahhing, I was debating for a little bit making this just a single piece, but I am glad that I didn't end up doing that, because now these three parts, this part here, and this part here, and there was another one as well. So I think maybe the ring. There's a couple components here that now have close to or over 100 features in them, which is definitely the most I've ever had. Let's see, this guy. Okay, this one's only 84. I think it might be this red one is 102 or something like that. So they're getting pretty big, and I think that if I tried to combine both of these arms into a single piece, that part would have been absolutely enormous. Not to mention, very, very, very difficult to model, I think. Yeah. However, doing it this way was, I think, a good kind of compromise, where I have now... Also, by the way, I just want to preface this by saying I was up until 3 a.m. last night trying to finish this, so I'm a little bit tired right now, so I apologize if I'm a little bit more, I don't know, difficult to comprehend than usual. Yeah. Yes, so I decided to, as a method to fix these two arms together, I would have this like attaching plate, and this would fasten onto both of them with, I have, what are they called, threaded inserts in these 4 holes and the 3 on the other side. And I've also made this little like T feature just to kind of like help this part kind of snap in a little bit better. And I was actually very surprised by this. I actually don't know what, maybe I didn't even add any tolerances in. Yeah, okay. It doesn't look like I've added any tolerance at all into that, which kind of explains why when I printed this off, the first time I put this bracket into the red piece, it like very, very solidly snapped in. And it was not like, I didn't even really need the bolts to hold it in. It was very, yeah, well in there. And that has worked really nicely. That works very well to like hold these two pieces together. Now, as I was doing this, I was kind of like progressively changing things around. And one big thing that you'll notice is this is the old design from last week. You'll notice that the hand motor is not super far up the aluminium extrusion, but it's kind of, I mean, how far is this? We can just measure it. This to this is, yeah, 50 millimeters or so. Center axis, yeah, 53 millimeters from the bottom of the extrusion to the hand spool. Now on Jugglebot, in the equivalent spot, the hand motor is pretty much right in the middle of this aluminium extrusion, which I think is the best spot for it to be in. It just means that the string has a larger distance to like move over, so the angle between like this spool and, sorry, the angle between this pulley and this spool is not very large if they're far away. But I was thinking that like, this is nice and tidy, but if I really want to tidy this thing up, I can get rid of this component and merge them with the red one and have that all be one solid piece. And that will work nicely with wanting to combine these two sides together, which is, as you can see, is what I ended up doing. But that involves, well, the nicest way to do that involves putting the hand motor really far down. And this was my biggest point of uncertainty when I was going through actually making this thing. Like everything else that I had changed, which I'll walk through as we go, everything else that I changed, I was pretty confident in, except for this, because this, as the string spools up, it winds wider and wider and wider, and that angle starts to become kind of steep. Now, thankfully, it's not an actual problem, and I should be able to show you. So if we look at the back, where are we? Here. So we can see that spool is here, and as I wind the hand up and down, the light doesn't really get in there super well, does it? Yeah. You can hopefully see that the angle does get quite steep. Like down here, right at the bottom, the angle of that string is fairly steep, but it still works. And it doesn't cross over itself at all. So I'm kind of relieved about that. That was definitely my biggest anxiety. But it worked. And yeah, just getting all of that to fit was non-trivial. But there's there was a very, there were actually a couple very serendipitous moments during this where I was like, these things are working together very, very nicely. And I don't know, it kind of made me feel that like I was heading in the right direction. When like multiple things kind of line up and they seem to want to be in a certain way, I don't know, it feels kind of like that's the way that the thing wants to be. So what I mean by that for this specifically is, as I was working through this, I was thinking about how I can route the cables in here, because that was one thing that I was very unsure of with the older design when this ODrive Micro was higher up. I was like, how do I get the cables from like down in the bottom up to here, up to here? Like there's a bit of faff involved there. So that was definitely in my mind a lot when I was going through this redesign. And the way that I kind of knew that I was on the right direction is, where have I got it? Here. So as I was cutting along, I had the same, I don't remember if this was CAD'd last week, but I definitely described it last week, where I have the power cables running from this ODrive will go through this channel, and then the CAN cables will go through this channel. And as soon as I kind of like put all of this together, and I had the ODrive Micro down here, the hand one down here, and then once I put these channels in, and I saw where those channels line up, I thought, yep, this is meant to be. These cables just appear directly where the ODrive is. That is so good, because all of these cables I can daisy chain along, and I can just go all the way along. And so having this ODrive right next to where these cables just spit out is perfect. That is exactly where I'd want them to be. I mean, right now these are a little bit close, but this is without even, I was not intending on these being lined up like this. I was just working on this red part separately, working on this black part separately, and then as soon as I put them together in the assembly, that's how it lined up. And yeah, that was pretty nice. I was very happy about that. So let's go back to here. So you can see now I've changed things around a little bit. I've added a bit more space in here, but the general idea is still the same. So we've got the, I've now added this back plate as well on here, which is attached with magnets. So we can see these holes around here. Hopefully you can see them. There's like one here, here. I put 6 in here, here, and 2 down here. And yeah, that just snaps this outer case on, which covers up all the cables and everything. There was a bit of an oversight with that, because you'll see that this magnet, this one here, how should I do this? Section through this way. Yeah, nice. So this hole here is a magnet hole, and that magnet is like right next to this blue clip on the ODrive Micro. And that blue clip is one that I need to put a plug into. And I did not realize that when I was designing this case. And so the case has a, if I can hide it, if I can hide this, the case, like, to fit the magnet in there, we need to have like a bit of plastic around the magnet so that it actually stays in. And these are all print in place as well, so they are not coming out anytime soon. But because I need plastic around the magnet, and that has some size, that very much impedes this clip. And as you can see, there's no way that you'll be able to get that clip plugged in while the magnet is there. And the same thing happened a little bit further down with the actual cables as they were running down. And so what I ended up having to do, I don't like really showing this off, but you know, got to be honest. I had to come in with my soldering iron with like a blade tip and just cut away all of this, which was a bit tedious and kind of hard to do, so I didn't like ruin the surface finish on the outside, but it kind of worked. And I did that because I didn't really want to have to reprint this, because these magnets are print in place, they are pretty annoying to get out of here. So I really didn't want to have to reprint this if I didn't need to. So I figured it would be a little bit easy just to like trim off as much as I can. And then this way, if I ever do need to reprint it for another reason, I know to make this change, and then I can have it be perfect next time. But it's a very satisfying snap fit. It doesn't... I was really trying to make this as like sleek as I possibly could, and I didn't anticipate... Well, I didn't really know how big the cables would be sticking out from the electronics in here. And it turns out they're sticking out a little bit more than I planned for them to. So when this goes on, I have to kind of... If I want it to be kind of flush, I have to like massage it a little bit. But even then, there's still a very small gap in there. So I may end up reprinting this later anyway, just to have it be a bit bigger. And actually, I do plan on reprinting all of this a bit later, but I'll talk about that later. Alright, Alice says, if you need filament, I get it cheap from a dude in Bendigo called Frankly 3D. Good to know. I will look into that. Yeah. I've been using the bamboo filament a lot lately because it's just so good. Like this, I seriously think this red filament is like the best filament I've ever used. It's just PLA basic from bamboo, and it comes out so nice. It's such a good finish. Like that, the hand is so clean. It's very good. Very, very, very good. So I've got high expectations now for my filament, but I'll definitely have a look and I'll check him out. Thank you. All right. Before I get too distracted continuing on, because there's a lot that I can talk about with this, let's go to my slides. Yeah, so I was planning on starting out going from the base up and working up from my changes through there. And I'll continue along that front. So yeah, last week I had, because I didn't know exactly where I wanted to put these electronic components, and there's a lot of wiring through here that I will need to have some, well, that I did need to route in some fashion. I wanted to make sure that the base was forgiving for any kind of orientation of how I wanted to lay these components out. So what I was planning on doing in here is I had all of these holes in here, and I figured that this way I can just print whatever brackets I want to print, and then I can just screw them down, which is like, yeah, cool. Like, I don't know, it's a bit of a faff having to screw things in. So what I ended up going with instead, and I mentioned this last week, is I found this thing called Multiboard, and I've put a link in the description for like the single cell of the multiboard that I ended up using to do this, where I'll show you just the box. I basically taken this multiboard stuff is like a grid. Actually, I've got one here. I've got some of the little demo pack. It's basically a grid of octagons, and these octagons have little features in them, and like all of these holes have screw threads in them, and you can basically snap things in. So like this is like the basic snap. You can just get it and pop it in, and then it stays in. And so you can like take them out, you can put them around, you can orient them whichever direction you want. They're very handy, and I can very easily see how this can be the sort of thing that you can kind of go pretty crazy with. Like if you covered an entire wall with this, then you could have whatever mount you wanted for whatever tool you wanted. Like this thing behind me where I've got like all the balls mounted and like a bunch of tools and stuff, I'm like kind of low-key considering. I think if I do that sort of thing again, I will definitely use this sort of feature. So you only need a couple screws in the corners of each panel, and then you can just attach whatever you want at any time you want. It's very cool. Definitely recommend checking it out. But it's a little bit of a rabbit hole that you can, I think, get sucked into pretty easily. So I wanted to, I wanted to use something like this, and this is what I ended up using to provide a bit of modularity, and that way I can have a bit of freedom with where things sit, because there are some wires that have fixed lengths and they have like stiffness that's very hard to predict how it's going to actually physically sit. So I wanted a bit of freedom. And yeah, so what I ended up doing was basically tiling the base, as you can see, with this multi-board cell, and this way I can snap things down wherever I want, as long as it's like around there. And that worked very, very well. So you can see a photo here. Of course, the base is all in purple because I ran out of black. Alice says, absolutely love multiboard. Nice. They use some awesome printing techniques like stacking and split parts. Yeah, there are some very cool techniques that they've got. Like I actually have an example of that here. So this, I actually don't know what this screw goes to. I only printed off half of the demo pack thing because I needed to use my printer for other stuff. But there's this screw that is used for something, and I think this is what Alice is referring to, where they have, this is printed this way. So it's like unfolded, and that way you get like layer lines through this way, and then when you fold it, it becomes a screw, and then you can screw that in. And of course this, I suspect this only really works because the pitch of this thread is enormous, but it does work, and it's a very good technique for having that screw be super strong and very easily printable. And yeah, so here we can see the base, and I was very happy with myself with figuring out, well, thinking of using a, what are they called? Like a bus bar technique. So a big question that I had through this process at a couple points, both inside the box and also a little bit higher up, is that I have multiple components that all need to be wired together, but I may want to change them in the future, and I really don't want to have fixed wires soldered into each other. That is the way that I used to do things, where I would say, oh, cool, I have a wire, like this thing needs to be connected to here, which needs to be connected to here. I'm just going to make the wires the length they need to be, solder them together, cover it in heat shrink, nice and clean, great. But it's really not at all nice and clean if you need to make any changes ever. That is so hard to deal with. It's really not future-proof. You cannot make any changes at all. And I have had enough like hassle dealing with that now that I don't want to do that again. So I wanted a different technique. And my original plan was to just use the Wago connectors. So I just have a couple of these sitting around inside the box. I would make a little mount for these so they could snap down onto the multiboard, and that way I can have like a 12 volt Wago connector, a ground Wago connector, and so on. Which kind of worked, but these take up a fair bit of space. And actually, I've got a good video here. I'll make sure that we can hear it. So I was doing some testing. Where's my mouse? And you can kind of see the problem with the Wago connectors. Let me turn your sound on. So for some context here, what I was doing is I was just testing to see if the base rotating was working. So I had it, and also so that if I was also wanting to check if the encoder, the yaw encoder, was working. So I had it set up so that the teensy would read the encoder position and then move the base in the direction that the encoder is turned into. This is of course not exactly not at all how it's going to work in the future, because the encoder will rotate with the base. But I was just doing it as a test, so that way I could rotate the encoder, and then I could make the base move at the same time. Here we go. So it works, but everything definitely needs to be held down in order to work at all, because these everything is just sitting up too high, and there's a gear that sits in the upper ring here that we can actually see. You can see this blue gear in here. That is a very hungry gear, and it likes chomping up any cables that come near it. So whatever I ended up doing needed to be very low profile. And what was the straw that broke the camel's, well, the straw that broke the Wago's back was that I only have two types of Wago connectors. I've got ones that go directly straight, and I've got ones that connect 3 to each other. Which is very annoying when you need to connect 4 things to each other, which I do here. So here in the box, I have, for example, 12 volts and ground need to go to the teensy board over here. We need to go to the motor driver board over here. And we need to go to the slip ring. And something else. Why are there 4? Oh, of course, the output on the out. Yeah, we need the inlet and then those 3. Yeah. I was like, surely there's 4th. Yeah. Which becomes a problem when you're using these Wago connectors, because if you want to use this to connect 4 things together, you have to use 2 of them, and then you need a little bridging cable to connect the 2. And it very quickly becomes very messy. If you ever need more than what one connector can handle, it just balloons out and it just becomes a big mess. So this was actually late one night during this week. I was like, how can I connect these things together? I want it to be really neat and tidy. And I wanted to do the same thing up the top as well, because where we have all of these cables are coming together, as I've described. It's like, oh yeah, we have this great serendipity of the cables lining up very nicely, but we still need to connect them together somehow. And I was thinking of having the Wago connectors mounted onto the side over here somewhere, maybe, but they're kind of big and they wouldn't really fit super nice. But after a bit of umming and ahhing, I came to this bus bar idea, and it is so good. I love it so much. Where I basically I've got a better photo up here. I've got a multi-board panel, a little snap that snaps in down into the base. It's got a single bolt coming up through the top, and I can just use what are they called? O-ring spade connector things. Slot them onto the bolt, tighten that lock nut down, and then that's secure. And they're all connected, and they're not going to come apart. And it's very easy to change in the future, which is the main thing that I like about this. I've already had to undo the wiring a little bit on the upper section, which I'll show in a bit. And having it this way, it's so good. So easy. Yeah. Yeah, so these boards, like you can't see them, but underneath this board and the main Teensy board over here, I actually have the earlier versions of the Teensy board one, where I've basically got the board screws onto here. There's a little cutout section to allow all of the pins to come through because they stick through a little bit. And then on the back, we've just got a single snap. And that snap just snaps in and yeah, holds the board down. And it works. It's great. Yeah, and so you can see I've also got another one over here. This blue one here is just to hold the cables down. And I printed off a couple of these, but I only ended up actually needing one because as it is, this is enough to hold all the cables down. So everything is down enough that it doesn't get tangled in the hungry gear. And yeah, it's all worked very nicely. I would also like to just draw attention to, I have now some input capacitors on, some decoupling capacitors on the 12 volt line that comes into this. This was a suggestion from someone last week, I don't remember who, apologies. But thank you for suggesting that, because it's possible that there'll be a bit of noise on this 12 volt line because it's going to be coming over like a fairly long span. So I've just put a couple decoupling capacitors in there to separate it. Flyzy says, how is the bolt embedded in the plastic part for the bus? Does it have a hex-shaped hole for the bolt in? Yes, that's a very good question. I am glad you asked. Let's have a look. So if you want to check out the CAD here, there's, as I said, there's a link in the description, and all of the electronics stuff is in stage 1, and then electronics related, and then we've got multi-board snaps. I know it's a bit of a mess with the cables, but with the folders, but it works. So this is my bus bar snap. So what I've got is a M5 bolt sticks through the bottom and pokes out. And then in here is another lock nut. So you obviously can't see it in the photos because the spade connectors, the terminals are covering it up. But there's a lock nut in here. So that way the screw just comes through and screws into the lock nut. So once that's all done up tight, that can't spin at all. And it's just firmly sandwiched into the plastic. And then we've just got a free peg standing up and we can hook things onto it. Yeah, so it's fairly straightforward. And this is the first time I've tried this technique of like using no supports by like staggering things like this. And I believe it worked pretty well. I actually don't remember paying any attention to that when I got the parts off the bed. So I guess it worked. I just grabbed them and put them straight in. Yeah. All right. Yeah. So that's... Oh, actually, no. There's also on the base, there's 2 other changes that I made that I haven't put in the slides. One was... too many folders. All right. Yeah, one is for the cables that are coming out of the slip ring. So what I've got in here now, I've really wanted to be as neat as possible. You can see in these photos that all of the cables, like these motor cables, run in through this slip ring mount thing because they're kind of closer and I didn't want to bend them super tightly. But I was kind of hoping that all of these cables would be a little bit neater, but I kind of got to... For a lot of the things this week, I had very noble intentions, and then I would realize how long that was going to take, and my intentions, my expectations were lowered quite a bit. So this is as neat as it's going to be for now, at least. But yeah, you can see I was trying to like be kind of tidy with how the cables are routing through here, and what that looks like in the CAD is like this, where we've got a channel through here that the motor power cables run through, and that pops out right next to the motor driver. So those cables can afford to be pretty tight. They're a little bit longer than they need to be, but I've got more to talk about that later. We've also got a channel for the encoder cables that's a little bit wider. You can see that kind of runs up around here. And then we've also got, it's kind of hard to see. Let me see if I can... This might work. We've also added in a channel for the slip ring cables. There we go. So this line here that's labeled cables, those are the slip ring cables, and I've obviously just modeled them as like a straight thing, but they are indeed flexible, and they can bend through here. Now, I want to note now something that I have learned in the last week, which I will probably bring up again and again this stream, is that one thing, my biggest regret in a lot of the things that I did this week is that any time I was doing any modeling with cables, I should have added a lot more. I should have been a lot more forgiving with how, with where the cables are positioned, basically. Because you can see in this model here, I have it nice. So like that, the model of where the cables are and my channel for the cables are perfectly concentric, and there's not a whole lot of room to move those cables. If in reality the cables are not exactly where I put them in the model, then I might have problems because they don't line up perfectly. Because I've only added however much tolerance that is, not much, and it doesn't have a lot of other room to go into. And as you can probably guess, the reason why I'm drawing so much attention to this is because the cables, in fact, were not exactly where I was expecting them to be. And there were a few times, as I already showed you with the changes that I made on this part, there were a few times this week where I had to take my soldering iron and do a bit of melty to get things to work. But that did end up working. I basically just like gouged out a big, let me hide this. I basically gouged out a big opening around here because I think the cables were actually a little bit closer to the edge than what I have them modeled here. So they were getting like pinched by this highlighted edge here. So I basically just cut out a big channel, and that worked. And now it fits in. But it would be great to not have to do that. And I fairly easily could have put that in the model to have a nice big funnel, just in case the cables were not where I thought they were. And you can maybe guess that the same sort of thing happened with these cables as well. Yeah. Okay, the other big change, I'm realizing as well that there's actually two more changes that I've made on the base. One of them is that last week I noted how the prototype base that I printed off had actually shrunk after I printed it, which meant that these screw holes that I had printed off, the holes that I was putting the bolts through to fasten the big bearing to the base were not quite where I wanted them to be. In the model, they are perfectly concentric with the bearing, but of course, once the print shrinks a little bit after it's been printed, then those holes no longer become aligned. And I noticed that in the prototype print that had this happen, the holes had only, the whole thing had only shrunk ever so slightly, so the holes were only a little bit off of where they needed to be. And they were so close, in fact, that I was actually able to just brute force it and like warp the plastic a little bit to get those bolts in. And that worked, but it was very tedious to screw the whole thing together, and I didn't want to have to do that every single time I was putting it together and taking it apart. It was a little bit more force than I would be comfortable doing all the time. And we had a couple discussions on last week on how we could potentially fix this. I really like someone's idea. I don't remember who it was, but someone had that idea of using a threaded rod. So you have a threaded rod sticking up through out of the base, and then we can basically just slide the big ass bearing on top, and hopefully that might be a little bit tricky to get the alignment working, but I suspect that would be a little bit easier to like bend the threaded rods when they're a little bit longer, and then we can kind of like slide the bearing down onto it. I think that would work fairly well. But what I ended up doing is basically having a section of these holes that's a little bit wider to allow the bolts to just kind of slide in a little bit initially, and that way I can put the bearing on, put the 4 bolts in, not screw them in at all, but I can just rest them in, and that way the bearing is held concentrically. And that allows me to do tests like making sure that this part spins the way that it's supposed to spin. So I can test that without even needing to screw anything in. And yeah, that actually worked quite well. And then once I want to secure it, then I can just fasten all of the bolts and get them to go in just that last little bit where they actually bite into the plastic. Yeah. I have also, you may notice as well that the lid now, so last week, the lid did not cover the whole thing. We had this exposed, like outer side of the big bearing, and now it's all fully covered up. And to allow that to work, what I've done is, I believe I described this, I believe I was hypothesizing about this last week, but I basically attached the big gear to the inner race of the bearing with only 2 bolts initially, just this one here and this one here. Then I can attach this whole bearing onto the black base with the 4 outer bolts as I just described, and this allows me to see in like this, which is very convenient. And I realized that this answer was like staring me in the face. I spent a fair bit of time trying to figure out how I can put this together in an easy enough way that still allows me to actually test things out. Because of course, once the lid is on top, I can't get access in there anymore, and I can't change any of the wiring around. I can't, I don't know, like diagnose any of the pins on the electronics. I can't do anything. So I would like to try to be able to test as much as I can without the lid on top, and then only once I'm sure that things are working, then I can put the lid on. And I realized that the answer was just staring me in the face, because the whole time I've been doing all of this modeling, I've been modeling like this. And I'm like, oh, if I'm modeling like this, why don't I just make the thing like this, where the lid's not on top, and then I only put the lid on top once I'm ready to. So it was a bit obvious, and that's what I have ended up doing. And yeah, so once I've confirmed that everything is working, and you could see in the video before where I could get the thing to spin around, I was like, yep, cool, the gears seem to be engaging all right, it's all working pretty fine. Now I can put the lid on top. And once the lid is on, it covers up, how can I show this? Nope. Come on. Come on, Onshape. Unhide. I don't understand why it has such a hard time unhiding something. I think I just deleted it by accident. Alright, whatever. Yeah, okay, here. Oh my god. Alright, yes. We can see once the lid is on top, the bolts that go into here to fasten the outer race of the bearing into the box, into the base, that has a nice little channel cut out. So that way this part just rides over the bolts and doesn't come in contact with them, because these bolts are fixed. Everything on the outer side here is fixed. This is not moving at all. But this lid will rotate. So we've got this channel in here to allow those bolts to slide underneath. And then we have, to actually secure the lid down onto the bearing that spins on the inner race of the bearing, we have the remaining 2 bolts. So as I said before, there are 2 bolts that only work to hold this gear in temporarily. And then once we want to put the lid on top, then we can use these remaining 2 to secure the lid. And those also go through into the ring, into the gear. So the gear ultimately is being held by 4 screws. Yep. And to fully confirm that everything on the outside is fixed, I have realized that I mentioned last week that because this robot is going to be up on the shelf behind me over here, and my cat likes to go up there despite me really not wanting him to, but he still does because cats are assholes. But he goes up there a bit, and also like this is probably, I mean, this is actually a fair bit heavier than I was expecting it to be, but when it's throwing, especially if the arm is at like a fairly steep angle, when it throws, it's possible that that's going to have enough inertia to actually like shift the whole thing. And I don't really want this to be moving around all the time. I would like to be able to just kind of lock it down and then have it not move anymore. And I don't know why I didn't think about this before. I guess it just was a matter of it becoming more of a real thing that to make me realize that this should be done. But I've added in these flanges, this flange on the outside with some screw holes in it, so that way I can just bolt it down onto the shelf behind me and it will never move. Yep. And you can also see I've added on motion capture markers onto the lid of the base here. I originally also, and I actually still have them in the model and they were printed off as well. I had motion capture markers on the base, and I was thinking, okay, I can use that to figure out where the base is, and then I can just use the encoders to figure out where the platform is. But I pretty quickly realized that I actually don't really care where the base is, because this top part can spin infinitely. I mean, I can spin this around as many times as we like, and there's nothing to get tangled up because of the magic of a slip ring. It really doesn't matter where the base is. The base could be in any orientation whatsoever. Literally the only thing that is affected by the base is where the cables plug in, and that's it. So yeah, I removed the mocap markers on the base from the model, but I haven't gotten rid of the holes yet. Just haven't gotten around to it. But I do have markers on the lid, and those are actually on the real thing. And hopefully these are random enough so that the system won't get confused about what orientation this is. I feel like this should be fine, these 5, and it should be pretty resistant to occlusions. We'll see how we go. I also have checked, and I believe 3 cameras can see that spot. 3 of the motion capture cameras can see. 2 of them can see it very, very clearly. I've got 2 up here that are basically staring right at it, and I think a 3rd camera can see it a little bit. So I think that the tracking should be pretty decent up on where Ball Butler will be. So I think we should have pretty good readings for where the position is using these markers. And you can see I've got 1 very conveniently smack bang in the middle, so that should be a very easy reference point to take to find the origin of Ball Butler. Fluzzy says, do they have to be special material or can you just 3D print the motion markers? That's a very good question. You cannot just 3D print them, they are special. They are retro-reflective, which means that they send light back to where it came from. So, actually, a good example of this is the balls behind me. So you can see as I move around, see like right now, those 3 grey balls there are dark. If I move here, they become bright. If I move here, they're dark. And here they're bright. The reason for that, and those are the same, they're covered in the same coating as these markers, except these markers are obviously way smaller. So you can see we've got like, yeah, one down there. Yeah, so they send light back to where it came from. So I have a light right next to the camera here, which is part of what's lighting me up so nicely. And if I move out of the way, that light bounces off those balls and bounces straight back to where it came from, which is pretty much where the camera is. So if I'm blocking them here, if I'm blocking that light from hitting those balls, then nothing gets bounced back. But yeah, they basically bounce back light or any radiation back to exactly where it came from. And they are very expensive, which is actually, that's the reason why I actually ended up taking the ones off of the base. I don't know if I would have realized that I don't need them on the base until much later on, except I basically ran out. I don't have enough of these small markers to have the 5 on the lid here and the 4 on the base. And I was like, oh, what am I going to do? I don't have enough markers. Like, I don't really want to buy more because these are like $12 each. And I'm trying to find a cheaper way to get them. But in lieu of that, I don't have enough of them to put them on the base as well. But I do have some bigger ones. And I put in the model, I put the big markers in here, and I just hated the way that looked. It was just like these giant spheres sticking out, and it was just so janky. So only a little bit after that did I realize, oh, actually, I don't even need these at all. I'm just going to get rid of them. Yeah. Yep. Cool. All right, so that's pretty much all the changes to the base that I've made. And yeah, it all prints very nicely, and happy days if I just had more black filament. But whatever. Let's go back to the slides. Okay, now pitch axis changes. I've got a funny picture here. Can you see the problem with this? Because I only saw the problem with this after I actually installed it. Like, once I got to this point. The problem, of course, is that the ratchet is the wrong way. And I still don't know how this happened. I am very, very confused by this. Because throughout the modeling process of this robot, I have changed the way that this string is fed through. And actually, I'll give some more context here as well. So this ratchet is for the pitch axis. So this goes up and down, and the way that actually moves, of course, is that we have a string that runs along here. That string tucks into that hole and wraps around that ratchet, and then on the other side, it comes up the top and wraps around this ratchet up here. And that string has to be fairly tight to allow this mechanism to work with no backlash, which, as far as I can tell, it does, but more about that later. Yes, and so I've played around a little bit with having the ratchet go in the opposite direction, just as designs have changed. So I actually have 2 versions of this. I've got this version and a mirror version, and this is actually the mirror. So I'll show you in the actual CAD. So I've got, this is the default version, and I've got my little tensioner tool that I made to help tension this thing. And just for full context here, I have 3 bolts that come through here. Those bolts are attached into the tensioner, so they just stick out the end, and I can actually show you that here. This is my little tensioner tool, which works amazingly. I'm very keen to, honestly, one of the big things that I'm keen for making a proper video on this about is just to show this mechanism. It is so satisfying. Yesterday when I was tensioning this up, the string was like way too loose. Like I had just tied it up manually, and it was like 5 clicks of this. Put it in, click, 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 done. Fully tensioned. It's as tight as I want it to be. I just remove the tool, and it's all clean. It's so good. It's so neat. I'm very, very, very happy with this design. But it can lead to some confusions because the ratchets are not very obvious. Like if you look at them from this direction, it's like, okay, cool, the arms are going that way. But then if you look at them from the other direction, the arms are going the other way. And it makes it very hard to make sure you got the right one. So this is like the normal version. And then I've got a mirror. And the mirror is, as you would expect, it's literally just the thing mirrored. And if you go into the CAD here, so what I did is I click on this, I go, yep, cool, ratchet spool. I highlight over it, it says configuration mirror. I print off the mirror, I print off the mirror configuration, and this is what I get. And it's like, how, what? Why is this happening? So I ended up having to print off the other version, the non-mirrored one, and that ended up being the correct one somehow. I don't know what's going on there, but yeah. This was such a funny thing for me because I don't know why, when I made the earlier prototype for this guy here, when I made this, I didn't really have that much trouble with getting the strings through and like getting it into the ratchet and then getting the ratchet all tensioned up, like getting the string into the ratchet at least. That all went pretty smoothly. But for some reason this time, I had a much, much, much harder time trying to get the string into that hole. It might have just been because I'd like partially constructed or partially assembled some of the other components and there was just kind of stuff in the way and I didn't have as much ability to like move it around as I did when I put this one together, maybe. But in any event, I had a really hard time getting that string through. And after I finally got the string through, after like, I don't know, 5 or 10 minutes of stuffing around, I got it all threaded onto the ratchet, all nice, ready to go. I insert the ratchet into the hole and I'm like, what the fuck? Why is it backwards? Thankfully, I didn't have to put the string back through again. I could just untie the ratchet, print off a new ratchet, wire it up again, and then put it in. So it wasn't too bad, but it was a bit of a stupid thing. And yeah, you can see I've also added a lot of fillets around here, but there are, in addition to the changes that I described before with like moving the hand motor, I don't get why that changes the aspect ratio. In addition to moving the hand motor over to this side and like making this all a lot more compact, I've also improved the cable routing, I think, quite a bit. So now, like last week, we had the cables would run out from the slip ring. You can see these cables here. These would run out through this curved channel and then they would come out. They would get cable tied down onto the plastic through here. There's a cable tie would go through this slot and then up and over, then into this channel as deep as they would want to go. And then they can go up around this channel and loop around. They would run into this block here, but I figured that would probably be okay. And by that point, they would start to arc around to go down. Now I've improved it quite a bit, I think, by making that channel a lot deeper. So now, rather than having this channel pop out early and then get cable tied down, that channel just goes the whole way through, which fits really nicely through the 2 bearings in here. So maybe, what view would work? Through here, I guess. Actually, that's good. Yeah, so now we can see these 2 bearings on the sides, and there's a nice bit of room in the middle here where there's just current, well, the previously was just plastic, just sitting there doing nothing. But now we've got this nice, elegant channel cutting through, and that poops out right at the this cut in section here. So that way the cable has to go into this deep cut. It comes up through the deep cut. That continues around. We also have a cutout in here, but you might be worried. You might be thinking, oh no, we can't have a cutout in here because there's a spool in here, and the spool needs to be here so that we can tighten the string, right? Because the string has to run up and down over this edge. That comes down, wraps around this spool with the ratchet that we just described. So we can't have this cutout because there's a spool there. But this is Serendipity number 2. It's great. Where's the better? Oh, we're in it here. Let me refresh. I don't know if it's because I'm in Australia and our internet is shit, but sometimes Onshape just has a hard time. But look at this. This is so good. So part of this spool is the ratchet, as I have shown, but another part of the spool is the actual spool itself that the string wraps around. And now it's worth keeping in mind that in operation, this is just sitting here. This is not moving at all. Once I've tensioned this up, the fact that this is a spool that the string can wrap around is just like incidental. It doesn't actually matter. It's basically the string is locked. It can't move. And it was so, I could not help but smile to myself when I realized that the section where I want the cable, like this fat cable that's going to be running up through here, I want this to run nice and tight and like, yeah, cleanly up over this corner through here. And I was so happy when I realized that that lines up perfectly with where that spool drops down. It's like, I did have to add this chamfer in here just to like cut away that last little edge of the ratchet. But my God, is that nice. It's so good. I love it. Yep, I was very happy about that. And yeah, so now the cables basically run up through here, through here. They then come into here. There's a cable tie that passes through this channel, another one that passes through this channel just to like make it extra locked in, and then the cable pops out through here. Where then we need some way to merge, to like wire up all of these cables in here. So we've got the 4 cables that come through that channel that I just described. Those 4 cables, 2 of them need to come through here, 2 of them need to come through here, and then 2 need to connect onto all 4 of them need to also connect onto this ODrive. And I love the bus bars. It's so nice. So this is what it actually looks like. How good is that? That is clean. And also you can see, maybe on this side will be better. So that cable routing has worked extremely nicely. So the cable pops out through here, as I showed, comes up and over. I had a bit of a play around with like the different lengths here, and yeah, it's possible that a different length might be better than this one, but this does work, and like it tucks back up into the spine when everything's vertical, and then it's still long enough to allow this to fully extend down to, I've like set the limit of the string here so that this can only actually physically go down this far before the string just doesn't allow it to go any further. Of course, the mechanism can go a little bit further, but I wanted to have the string be like a safety kind of block so that no physical components break. Oh, so no, the printed parts break actually. And yeah, so that just tucks in, and on this side we can see that the cable comes up and over, comes through this cable tie, down through here. I know the focus isn't working, but hopefully you get the idea. Through that little hole, and then onto our bus bar. So I've got 12 volts, I think from the top is ground, 12 volts, can low, can high. And it's so neat. And as I said, I've already had to muck around with this ODrive in here. Yeah, where is he? In here. And to get that off with these cables in here is very, very difficult to do because there's screws in here that I just can't access because these cables are in the way. But because this is all just like bus barred on, it's very, very easy for me. I can just undo these 4 bolts because they're just into... I don't actually have these in the model. You can see I've just got like the bare thing here. I think I will update the model to include these holes for future prints. But for now, I just drilled holes in the plastic, inserted a threaded insert the bolt, and then you've got an electrical connection point. It's so clean. Of course, I did take a very, very long time to cut all the cables to the right length and to like get them all crimped. My God, the crimping, I don't want to go into that. It takes a very long time to get it all to be the right size, but it's definitely worth it. It has come out very nicely, I think. I'm very happy with it. I'm glad you think so too, Vlozzy. Yeah. Okay, so there's another problem that I ran into during the week, which I kind of expected to be a problem, it was so close to not being a problem. I'm pretty happy with how things went, all things considered. Is to do with this section up here, where I'll show you what I had last week. Nope, it's this one. Yes. So as of last week, we basically have, so right now, it'll it'll take a little bit of explanation, but it's worth it. So as I mentioned earlier, I wanted to make sure that the force that was like the motion to make this whole thing move, like arc up and down to pitch, I wanted to make sure that that motion was not being transferred just through this spool here. I wanted that to be transferred some other way. And as I mentioned, I added this plate on, so that way the whole thing is like really fixed together, even without this spool carrying any of that force. But aside from that, this spool still needs to rotate, like to spool and unspool that string. And I don't really love the idea of just having that string be wrapped around the spool with no support on the end. Like I could just have it hanging out here like this, and there doesn't need to be any support over here. We don't even need any of this stuff over here now. Well, you need the extrusion, but we can chop this off here pretty easily and have that spool just be cantilevered out. But I don't really love that idea. I think that that would generate some weird forces on the motor and probably not be too great for the spool. So I wanted to support it on the end here. And the way that I was doing that last week was to have these two brackets on the end here. So there's these two guys. My intention was that you can see I've just got like nice single straight hole that goes through. I would drill a hole or two holes through the aluminium extrusion with just a hand drill, because I don't have a, what are they called? The straight drills, the ones that actually allow you to, what are they called? The drill press? Yeah, I don't have a drill press. So I was just like kind of eyeball it, drill these holes through, get them all perfectly lined up, because, you know, I'm a handyman god. And then they would line up perfectly with this one, which has threaded inserts into it, and that would completely lock these two brackets in. These would not move anywhere at all. That would then hold a bearing that basically supports the end of the spool. But this did not work. I could not get those holes lined up perfectly, as you can probably guess. They were very close. I'm pretty sure they're within like 0.6 millimeters of where they're supposed to be. So, I mean, I'm fairly happy with that, but it was, yeah, definitely a bit ambitious to expect much more of that. So what I've got now is so much better, and I should have just done this at the start, is I have slots in both of these. So for both of these holes, there's a slot instead. And on the other end, rather than using a threaded insert, which is very hard to move once you've got it in place, I'm now using T-nuts. And I don't know if this will show up very well on the camera, but we can have a try. So you can see in here, I have now, maybe, hopefully you can just see that. There's a little T-nut in here, and that allows me to basically slide this thing up and down to get it exactly where I want it to be. And that has the added benefit of making sure that, like that 0.6 millimeters that I was off by is the concentricity of of these holes through these brackets with the hole in the aluminium extrusion. That is not necessarily the concentricity of the one that actually matters, which is the position of this bearing and this spool. I want those to be fully concentric. I don't really care. The other ones are just like there in order to achieve this. This is what we really want to achieve, is having these two things be perfectly concentric with each other. And my old approach allowed for zero tolerance on any of those holes that I had drilled or positioned. But now, what I did is I basically put this in loosely, so the T-nuts were just kind of hanging out in there, and that gave me like, I don't know, a millimeter or so of wiggle room on this bracket here that actually holds the bearings. And that, I believe, is enough. So I had that done up loosely, got it all lined up perfectly, and then tightened up the bolts on the back here. And this is important as well. Like, the reason why I've gone to this much effort and like drilled the holes through and done all of that is because if I have this bracket attached onto the aluminium extrusion the normal way, where you just like go through a bolt through here and then have a T-nut in here, if I had it like that, I wouldn't actually be able to fasten these bolts up because there's a big motor in the way. So I can't access this side. I didn't want to screw anything into the sides here because this side has the string running over it, but also more importantly, the other side has this big rail in it, and like I can't do anything there because the hand needs to slide past. So the only remaining surface that's available on the extrusion is on the opposite side, so I had to drill these holes through. Yeah, these bolts are also cut down so that they don't stick out the end. Yeah, but I I need to fix my fasteners library, but we'll get there. Yep. Cool. I believe that's all the updates to the CAD. And as I said, so this was still a little bit long. It was like 40 minutes or so of talking about the CAD. This was like, I don't even want to think about it. Probably like 15 hours of CAD. I started like literally last week after the stream. I just went straight into doing this. And it was like Friday, Saturday, Sunday were all just doing this CAD. Just changing these components over to be like this. And like have this magnet mount on here. It takes a long time to make these changes, at least for me. I don't know, maybe some people are faster, but yeah, it's a time-consuming process. But it's worth it. It comes together nicely. Now, there was another problem with my wiring in this case, which obviously now the wires are cut, which is a bit of a problem. You don't want cut wires. But more importantly, well, the reason why the wires were cut, I only thought to take the photo after I'd cut the wires, but you can kind of see, maybe PowerPoint will let me zoom today. Nope. Okay. Oh, I can control zoom. Okay, that works. Yeah, somehow, I don't know how this happened, but at some point, I must have hit this with my soldering iron or with like the heat gun or something and melted the insulation on some of these wires. So much so that the wires were actually able to contact each other. And that obviously ruined my SPI signal coming from this encoder. Oops, this is the encoder down here that runs up to this ODrive Micro. And yeah, so that was obviously ruining that. And I also realized while I was doing this that I actually need, because of the way that these boards are laid out, and like the protocol that AMS uses for their encoders, you actually need the MOSI pin. If you're not using the MOSI pin, it needs to be pulled high. So I didn't actually include that in here at all. So I also needed to include a wire between 5V and MOSI, which once I got this replaced, once I got out these the grungy bits that got melted, I added that wire in as well. So now that's correct for anyone who's really paying attention. All right, so before I get into the problems, I just wanted to say that it's all good. Maybe it's not all good, but it's coming together and it actually works. And actually, before we get into the problems, I want to show you the demo of what does work, because there is one aspect of this that does work quite well. So let me just plug everything in, and actually I'll put you on. Why did that move? I had it all lined up nicely. All right, you can see my messy desk. All right, let's go here. So I can wire him up. And plug in the micro USB. Very nice. And I should be able to just turn it on. Bum, bum, bum. Are we alive? Yes, cool. So now I can set a speed and it will rotate around. Da, da, da. So that's rotating in one direction. I can rotate in the other direction. And of course, because this has a slip ring, we can go around as many times as we like. Spin, 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 spin. And we can go the other way. Dance, robot, dance. Yeah. And this is at half speed as well, so let's go full speed. It's pretty fast, pretty snippy. Also pretty loud. So I don't know if I'm going to be running it at full speed ever, but even at like the slowest speed, there's a certain range. Like if I do like a low enough PWM, then it just won't move at all, and the motor is not strong enough to like overcome the friction in the system. So this, I believe, is the lowest speed that I can go. I mean, okay, I think once it's moving, I can lower the speed down again, but it's definitely got a minimum speed. But I have a feeling that even that will be like completely fine. Like even like this is 30% speed. That's going to be more than enough for it to be able to get around to where it needs to go. So yeah, that works quite nicely. Now there is a weird sound, I don't know. I'll see if I can put it next to the microphone, see if you can hear it. I've got to bring the microphone to it. It's like every revolution is like a ticking sound. Right when the front passes here. Yeah. I don't know if that's coming up on the mic at all, but I don't really know what it is. It sounds kind of like one of the wires is hitting the gear a little bit, or something is like hitting something else, but I don't really know what, and it doesn't seem to be getting stuck, and I'm still able to do, I mean, we're up to 11 revolutions now, so it's not getting tangled, but it's kind of annoying to go in here, so I don't really want to open it up to find out. But yeah, that axis works very nicely. Flyzy's asking, that's awesome. What is rotational accuracy for that? Yeah, so I'll show you in the CAD. So this is being driven by just a brush DC motor in here, which I only have just the power and ground connected to. And so I can only command a PWM of between, the lowest that I found that works is 20% and obviously 100%. And so as long as I'm between 20 and 100% in both positive and negative, then I can get it to spin in that direction. But that's not getting us to a specific location, that's just powering the motor at a certain amount. And to know where we actually are positioned, we have this encoder in here, which is an AS5047P, which I believe is either 10 or 12-bit. So we've got pretty good resolution. I mean, I can show you the Arduino readout here. Let's turn it back on. So it's pretty good. Like we're hovering, I mean, we're ranging, but we're like plus or minus maybe like 0.002 or 3 revolutions, which is pretty good. I'm pretty happy with that. I figured that when I was doing my rough like calculations of this, I estimated that I would need a angular position like this yaw position needs to be within 1 degree, and this is what 0.0002 revolutions. So what is that in degrees? 0.00, let's say 0.005, 0.0005 times 360, 0.18 degrees. So we are like 5 times better than what I estimated we needed to be. And it's possible that I can modify this a little bit to improve that, but I'm not going to worry about that unless that becomes a problem. So it's good enough from what I can tell for now. Now, there is the question of like, if I do... if this is positioned very close to where it needs to be, but it's not actually where it needs to be, it needs to be like half a degree over from where it is, because I have a minimum speed that I can send this at, we might have a weird problem where it kind of like continuously overshoots. So there may be some funny control stuff that I might need to do to basically say, if you're like very, very close to where you need to be, deliberately massively overshoot, or like go far away from the target point and then approach it again from further away. And maybe that would work. I don't know. I haven't really done this sort of stuff before. So we'll figure it out as we go. But I'm pretty happy with that. And brush motors are so easy. So to get them to move, at least. It's possible that that problem that I just mentioned about like actually getting precise positions might be where the brush motor starts to falter. But getting to this point, super straightforward. And I'm very happy about that. But what is not as straightforward is the ODrives. Yes. But that's not the order that I've done this in, so I'll get back to them in a sec. So one, of course, through this process, this was not all smooth sailing. Some of this was smooth sailing. Some of it was very nice. All that, the serendipitous lining up of things, I was, oh, beautiful. Wow, loved it. But not everything was like that. Definitely not. Now, one problem that I had was with the getting the pitch axis to, let me go to here, on here, was getting the encoder that's down here, which is reading the absolute output position of this arm. It's basically saying like, this angle should be 0 degrees, let's say, this angle is like 30 degrees, and everything in between. So it's measuring that angle of this arm. That output is getting sent up to this ODrive up here with the intention of me being able to say, hey, you, Mr. Pitch Axis ODrive, move to 15 degrees. And then it will say, yep, it will move this motor however it needs to, as many times as it needs to, in order to have this encoder down here read out 15 degrees. So to move to like there, say, wherever 15 degrees is. And that works over SPI communication. So I've got 5 cables that connect into this encoder down here, and the 5 cables up here. And that is actually the same, that's this connection here, the one that I showed off. Now you'll notice that, oh, actually, it wasn't even this one. Lol, it was the other one. Okay, keep this same idea, but I have another encoder, the same type of encoder in here, and this one is communicating over SPI again in the exact same way with the Teensy directly. So this encoder is measuring the position of the yaw axis. So as the brush DC motor rotates, it spins that gear, which then spins the big gear on the outside. That moves the whole thing, and then through the slip ring, I have this printed part with a little channel in it. And as I described last week, there's a little peg that goes through this channel, and that means that wherever the big ring spins, wherever the gear spins on the outside, it will mean that this magnet down here will also spin the same amount. So you can see as I rotate this around, the magnet will also spin. Now, this encoder is reading what that output is, and that's what the output is that I was just reading in the Arduino readout, is the position of this magnet as read by this encoder. Now that goes straight to the Teensy. And for those who are familiar with microcontrollers, you may know that Teensies only operate on 3.3 volts. They are not happy with 5 volts, which is fine because SPI runs over both 5 volts and 3.3 volts. And you can actually see on this chip here that this is the other one, so this one is being run at 5 volts, but we can see there's a 5 volt pin and a 3 volt 3 pin, or 3.3 volts pin. And you have to kind of configure the wiring of here a little bit differently. You've got to like move a resistor and change one or two things. But you can use this chip in 3.3 volts mode, which I need to do because the Teensy can only send the CS, the clock, and MISO. Those ones can only run at 3.3 volts. So this needs to be powered by 5 volts. But you can see on my board here, bump, 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 5 volts out. I had designed, because when I was designing this electronics board, I didn't realize that I needed this to be 3.3 volts out. And so I had it all wired up because it was basically just convenient to have the 5 volt channel and the ground channel right next to each other on that Vero board. And so it was just nice to say, yeah, I can have this be 5 volts out. That's easy to do. But that means that the whole thing's powered incorrectly. And off the top of my head right now, I actually can't remember what I did to fix this. I think I was very tired when I did that. That was a couple of days ago. But I don't really exactly what I did to achieve this, but I now have it all powered by 3.3 volts. So yeah, I'm not actually sure what I did. I might have changed this to be 3.3 volts out instead of 5 volts. But in any event, this is now running off of 3.3 volts, so it can actually communicate with the Teensy. And I was kind of happy with myself there. What I was trying to do is I had it all wired up. I had the brush DC motor ready to go. That was good. I had the encoder nominally ready to go. As far as I could tell, it was ready to start reading and spitting out readings. And I wanted to have the demo setup that I showed before in the video, where to check both of these things at the same time, which is a bit dangerous, but I wanted to check both of them at the same time because why not? I'm impatient. Get them over with, confirm it all, move on. I wanted to have it set up like what I have here, where I have I can spin the encoder, and that will give a command to the motor. And that way, if this all works, then both of those things have to be working, because I can read from the encoder to get the command, and I can send a command to the motor. And if the motor is moving, then both of those things work, and it's great. But as you can probably expect, especially because I didn't have the wiring correctly, that didn't work. And the motor didn't spin, and now because I'm trying to test two things at once, I'm left thinking, oh shit, something here is broken, or is not working, and I have literally no indication as to what that might be. Now, for whatever reason, the point where I decided to start my interrogation was on the encoder, and I just took out my oscilloscope and started polling all of the pins. And I said, okay, is the encoder getting power? Do we have 3 volts? Do we have 5 volts? Because that was still when I was sending 5 volts to it. Yep, that works. Now I just move through the pins, and I see like one of the pins is doing something, one of the pins is doing something, one of the pins, that's not doing anything. And then I could basically say, yep, my meso pin is completely flat, it's not doing anything. Check the data sheet, oh shit, I need to power this all off of 3.3 volts. Because SPI is not tolerant, you can't have like, basically whatever power you send to this board is what that power, is what that board, whatever voltage you send to the board is what that board deems as being like high. So if I send 5 volts, then 5 volts is like the high limit. Well, like, yeah, approximately 5 volts is where the limit is for like what is considered to be a high signal. And then low would be like whatever it is, 60% of that or below. And because I was sending 5 volts in, but only sending 3.3 volt commands, those were too low to be registered as like a high signal. And so the messages were just like not getting through. Thankfully, where I started interrogating was like spot on where the problem was, and I was able to solve it fairly quickly, just a little bit of soldering change. And yeah, then it just worked, and it was great. And like all the brushed motor stuff was just easy. It's so much easier than brushless DC motors. Yep. So that was a bit of a time, but it worked. So I'm quite happy with that. Okay, now let's get on to the more pressing problems, the still current problems. One of them is that the hand movement is a bit chunky, and I don't really know why. So I'll unplug it. And let's see if this... So as I'm sliding this around, hopefully you can hear the sound. And I'm trying to push as like softly as I can. And it's kind of... It feels like gritty almost. And I don't really know why. It's very strange. Like, this is basically the same mechanism that we have on Jugglebot's hand, and the Jugglebot's one is a lot smoother than this. I'm thinking like it could potentially be like I really cleaned off this this linear rail before I installed everything. I have put lithium grease on it, but maybe I just haven't put enough on, and it's possible that this grittiness is just coming from the bearing itself, which would be ideal. But I'm also thinking maybe it's possible that like the bearing on the end here that supports the end of the spool, maybe that's not perfectly concentric with the spool. Or maybe the string is too tight. I don't think so, because if I loosen the string at all, then it becomes too loose and we get backlash. So this is as loose as I could possibly have it while still having what appears to be zero backlash, or very little backlash at least. But it's kind of chunky. And there's a bigger problem with this. Like the chunkiness in and of itself is like, yeah, okay, not necessarily a bad thing. We'll see. But I can't get this ODrive to calibrate. It just doesn't work. It gets like stuck almost. And I'll show you what that looks like. So let me just quickly put the power back in. So let's go to here. Why are you doing this? Why do you keep moving? My camera's got a mind of its own. Alright, and let's go to here. And I'll plug in Something that I do quite like is that if you have a look on the CAD, the USB ports for both of these ODrives are fairly easily accessible. This one does, if the arms are like in the vertical position, then this one does kind of conflict with the main ring. It probably would not have been a bad idea in hindsight to like shave off a little bit from the main ring to have a little bit of space for the cable. But yeah, it's good enough. But then this one is very easily accessible, and I do have a little cutout for the cable. All right. Okay, so we're plugged in. We've got our ODrive connected. I will show you this. Maybe we just put it like this for now. And I'll make it so you can see all the values. Yeah, that works. And we can move this over a bit. All right. So this is getting very current. This is what I was up till 3 a.m. doing last night. Trying to get these ODrives to move. Because I was so hopeful. I was like, okay, maybe I won't be able to get the first like inter-robot throw. All right, I can tolerate that. But it would be really nice if I could get all 3 axes moving. And I was like, blue sky dream. I was hoping that I could get them connected to my space mouse. That way I could like control the yaw and the pitch and at least the movement of the hand slowly, all with space mouse. And it's gonna be so much fun. It's gonna be so good, but we didn't get there, and I don't know why. So yeah, we're connected up. We've got ODrive 2 is all plugged in. We can see we've got we're under voltage because I haven't turned it on yet. Now we're good. We're ready to go. ODrive Micro X4, cool. Let's calibrate. We get the beep. But it just gets stuck. It doesn't go anywhere. And then it says pole pair CPR mismatch, which as far as I'm aware is like, it doesn't, like you have to tell the ODrive how many pole pairs there are in the motor, but I've done that. There are 7. And that's the exact, I've like copied these settings, like number for number, exactly what I've got on the Jugglebot's ODrive that controls the exact same motor in pretty much the exact same context. But this one doesn't work. I'm also getting a bunch of CAN errors. I don't really know why, but yeah, this ODrive, I've never gotten it to calibrate at all. It just doesn't go. So let's put that one to the side. This one is much more promising. The pitch axis. I can get it to calibrate. So we can do the full calibration sequence. Hopefully that's not too far up. And look at how smooth that is. I am so keen for when this actually is controllable. That works super nicely. It's like, oh, cool, promising. It's calibrated, we got a success. It's great. Now, let's go. Closed loop control. Let's actually get this thing moving. Now, the positions are kind of funny, because I'm pretty sure it's reading from the load encoder, which is like the encoder down the bottom, which is reading the absolute angle of the entire arm. But if I set like, I don't know, an input position of like negative 0.15, we get no movement. And like I can move this around with like the motor's like not trying to stop me at all. I can just slide it wherever I want, and it doesn't feel like it's trying to do anything. And I don't really get why. Like, it's trying to send out current. Like this, it's sending out negative 0.11 amps, which is not much, but when we do the calibration, it's the same thing. It's still it's also reading out like 0.1 amps. And I've tried changing my my position, my gains, and you can see here I've got like a position gain of like now 2000, and it's not doing anything. It doesn't want to move. And it's so frustrating because I know that it can. I know that there's just some little number in here that I need to change and it will just work, but I cannot figure out for the life of me, well, for the life of me at 3 a.m, what that number might be. And it's so close. So frustratingly close. So, yeah. Let's turn it off. I'm, of course, not really expecting anyone to know the particular answer to this problem. I just want to bemoan the situation that I'm literally very currently in. I have no doubt that whatever this is, it will be some very specific little problem, and I've just got to find the magic phrase that ODrive needs for this to work, and then it will just start working from then on, is my hope, at least. I'm a little bit more nervous about the hand motor one, because that's not doing anything at all. But yeah, we'll see. I'm like kind of like tentatively, I don't know, I'm aware of the fact that it might be necessary to swap out this ODrive Micro with an ODrive Pro in order to have the more performance that the hand motor might need if we're doing more aggressive throws. Now, one glaring thing that you may notice that if you've been following along the last couple of weeks, right now I just have this set up so that the hand motor will be breaking the motion of the hand manually, like by itself, like electrically. So whatever momentum we put into the hand here, that momentum needs to be sucked back out electrically through the hand motor. And you may remember that I really don't want to do this because I basically don't have the power situation set up to allow for that. And that, yeah, I basically, I don't want to send any power back over the bus. So right now, the reason why I have it as it is right now is because I just want to do very low speed testing, like what I was describing with the Space Mouse, where I would manually control all the axes nice and smoothly so we don't have any super aggressive starting and stopping. Of course, once Ball Butler is actually in operation, it's not like playground time anymore. We're doing actual hard aggressive movements. So what I want to do for that is to explore the damper idea that we were having a look at in the last couple of weeks. So some combination of the shock absorbers, which I have currently put them all away, but the shock absorbers and like the TPU little damper thing that I just showed, something along these lines up the top here to arrest the motion of the hand. So that way we basically command the motor to go like full speed, yeet that hand up as fast as we possibly can, and then there'll be like a mechanical brake to absorb all that energy. And I suspect that this will be possible with just a single printed part. So rather than having something that like goes onto the linear rail that I showed off a couple of weeks ago, I'm thinking I should be able to just make something that attaches onto these parts, or even potentially makes these parts just one single part, and then there'll be like some kind of stopper on there. And I really feel like it's possible to have like a variable stiffness printed part that's like printed in one go, and it starts off really soft because I want the hand to be able to come in and have like I don't want it to like bounce off of whatever damper I have here, at least not like aggressively. I really want it to just go up and then have that energy be gone. And maybe it can like bounce off a little bit, but as long as it's not like a really aggressive bounce, it should be okay. But I'm suspecting that it should be possible to make a printed part with variable stiffness so that it starts off really, really soft, but then the further you go, it gets like exponentially more and more difficult to press in even further. And I'm very interested to play around with, my thinking is that like with what I've got here, where like the black part, the outer part is TPU and the red inner is PLA. And I have a feeling that we could get some very interesting results by changing the thickness of the PLA liner that's on the inside of this. I think that could lead to some very cool properties of the resulting part. And it can all just be printed in one go, which is very nice. Patrick says, looks like you've not entered a 90-degree offset in the FOC. PWM is used to go to the actual position instead or generating a torque. Interesting. I've not needed to do that in the past, but that will be my next point of contact with this. Thank you for that suggestion. Yeah, so hopefully it's that. hopefully it's that simple. Well, yeah, we'll see. Thank you. Yes, so what's next is, first step is get the micros moving, and whatever that will take, we'll see. Hopefully it's nothing too complicated. I then need to check. I've been getting there's a bunch of like CAN errors, like bus errors that are coming up in the ODrive display. Oh, it's gone now. But yeah, I don't know what that's about, because as far as I can tell, the CAN wiring is all fine. Like I've got like my termination resistors are correct, and I haven't changed anything from before. I've only added in the ODrive Micros. So like I know that the CAN works on the Teensy board. I've like tested it communicating with itself, and that works fine. So I'm not really sure what's going on there, but hopefully it's just like a protocol thing. I don't know. We'll see. But yeah, I need to get the communication working between the Teensy and the Micros, and I will also need to make some kind of library that I can use on my Teensy to kind of like contain all of the commands that I will want to give to these two ODrive Micros, so that I can call them very easily in my main Arduino code. But that's mostly a ChatGPT job, I think, at this point. Yeah, so get everything moving is next. And yeah, God, we're so close. So close. All right. Now, for the real big news. The very exciting update this week is that I have not so much fixed, but replaced my emoji keyboard. It's great. I love it. I'm so happy now. It's not quite as smooth as the natural Windows emoji keyboard, but it still works. And what I'm doing is I'm using a thing called Flow Launcher. And I'm curious to know if this will come up. Yeah, nice, cool. So I can just I can click a button. I've got it hotkeyed. It's actually F7 now, not F6, where this will open up Flow Launcher, and there's an app within Flow Launcher. I don't remember off the top of my head what it's called, but it's like emoji something. I'll put a link in the description after this stream ends. But yeah, so I can just come in here. Once you open up Flow Launcher and type like E space, that opens up like the emoji thing, and then I can type whatever I want. And the search is actually better than what the Windows one was. So I'm pretty happy with that. If I searched monocle in the Windows one, it doesn't come up with face with monocle. What can you search on the Windows emoji thing to find face with monocle? I don't know what you can search to have that come up, but monocle doesn't work. But yeah, so I can pick one. Let's say I pick this one, and then I have another shortcut which it just enters it in. This is why it's not quite as smooth as the Windows one. On the Windows one, when you select an emoji and just like press enter, it will just like enter it into your text, whatever you're writing. But on Flow Launcher, the way to remove the emoji out so you can use it is to copy it. So when you like hit enter, like if I go in here, if I go in here and pick like waving hand, I hit enter, that copies it to my clipboard. So I don't want to have to like press enter and then paste every time I use it. So I've got another hotkey mapped to, in this case it's F3, to do that, where basically it presses enter and then waits a second, well, a third of a second, and then hits Control V. So now I can hit F7, find the emoji that I want, happy, get my smiling face, smiling eyes, and then press F3, and it will paste it into where I want to go. And I love it. It's great. It's so good. We all know how much I love my emojis, so I'm very happy that this is working now. Yeah. Yep. Also, one other update on my API exporting business from Onshape. So anyone who uses Onshape may be familiar with the pain, I don't know if other people see this as a pain, but I certainly do, of exporting things, where you have to right click on your part, click on export, wait for this window to open, find the file type that you want, hopefully it hasn't changed from before, and then click export. And then you wait a second for it to do what it needs to do, and then it exports. I don't like doing that. I wanted that to be easier. So I, last week, showed off an API thing that I made and ChatGPT made to basically do this exporting at the click of a button. I can just press a single button on my macro pad, and then the thing will export. And I mentioned last week how this was kind of unreliable. It was working like, I don't know, maybe 50% of the time. But I've been using it in the week since then, and it works every single time now. I have literally changed nothing. I think I've probably rebooted my computer once or twice, but I haven't changed anything fundamentally about the code or anything like that. But now, all this week, it's worked every single time. Interestingly, oh no, it is working now. Yeah, it just takes a sec. Yep, so that just worked. It's exported now from when I pressed it a second ago. It does take a little bit of time, especially for more complicated models like this, where there's multiple parts. but the end result is very nice. Like I've got it set up so that if you have a multiple parts in a part studio, it will export all of them with their correct name. So I right now have motor mount bracket step, and it removes all the spaces and like unusual characters and replaces them with like normal computer friendly characters. And I've got basebox.step in my downloads straight there. And then in an assembly, if you use this this API exporting thing in an assembly, it will export the entire assembly as one step, which I actually did for all of Jugglebot kind of accidentally, and I can't even open it in Bamboo Studio. It does not, Bamboo Studio does not like it. It's a bit too big. Yeah, so I don't know what's changed. I mean, as far as I'm concerned, nothing has changed, but now it works every single time. So if you want to get some nice speedy exports, then definitely recommend using this. I'm a big fan. Now, speedy might not actually be the right word there, because it does take a second, and like from when I pressed the button before to when it exported, it's maybe like 10 or 15 seconds in total. I don't know if there's anything I can do to speed that up. I think part of that time is just how long it takes Onshape to like generate the step to then export. But I personally still find this a lot better than having to do the right click export thing, because I can just press the button now and then continue like zooming over, making sure I've got everything exactly how I want it to be, or I can like change tabs, go do something else while that export is running in the background, and I don't need to do anything else manually other than just press the button once. So I'm very happy with that. I'm very glad that that's working. Fluzzy says, I'm sure the Flow Launcher window has a specific application so you could have an auto hotkey capture the enter key to copy it and directly insert it. It probably does. I have no doubt that between Flow Launcher and auto hotkeys, I could make this a bit more streamlined than it is, because like this hotkeying, this is actually not done through auto hotkeys. This is done through Logitech Options Plus, which I've got many thoughts about. If you use Logitech Option Plus, do not let it connect to the internet. It will forget your settings, and it's fucking annoying. You set up all these nice little shortcuts in all your software, and it's like, oh great, my mouse does exactly what I want in all my software, but then the thing updates and it's now forgotten it all. But no, it's made a backup for you. It's okay. But the backup was made after it got rid of all your things. It's like, what the fuck is that? Yeah, so now Logitech Options cannot talk to the internet anymore. It is on the version that it's on forever for me. But all of these hotkeys are just like set up with my like Logitech keyboard, and it works. It works well enough. Yeah, I'll change it later if I run into problems. But trying to not get too lost in my auto hotkey rabbit hole. Yep. All right. That's it. We're getting there. There should be a stream next week as well. So fingers crossed. I've got the motions sorted. I'm definitely not going to be able to get as much done in the next week as I did this week. I was really trying to get this done to get it to move for my 100th stream. But now the 100th stream is done, there's not really like a big one for, 100th video, but there's not going to be a big milestone like that for quite some time. So I'm going to go at a more sustainable pace, I think, moving forward. But yeah, hopefully we get some basic movements, and I'm so keen for the first inter-robot throw between Ball Butler and Jugglebot. I think that's going to be quite a momentous occasion, but we're going to have to wait, I reckon, 2 or 3 weeks. I'll set myself. We'll see. Cool. All right. Well, that's enough ranting. I think that's everything I wanted to say. There's always so many things that I don't remember to put in the slides, and then I guarantee in like half an hour I'll be like, oh fuck, I wanted to say that. Oh, I wanted to say this as well. But hopefully this was coherent enough and has sated your Jugglebot curiosity for another week. And yep, cool. Well, I hope you found that interesting. And as always, if you have any feedback on any of this, please do let me know, because that does help quite a lot. And yeah, I will see you next week. And until then, have a good one.